also we are going out of the time. So let me introduce Mr. Abdul Rafiu. He's also an expert and Microsoft MVP. And his session, his topic is training models, not just machine, building human-centric centered AI that listens, see, and includes. I mean, the topic itself very exciting, and I myself is very exciting for this session. So over to you, Abdul Rafiu. You can share your screen and start the session.
All right, thank you, John.
Mhm. Yeah, we can see you, and I'll bring your screen also here. Yeah. So we have now your screen also coming in the here, so you can continue.
All right. Is my screen visible?
Yeah, we can see your screen.
All right, thank you. So yeah, I'm Abdurrafir Zofa. I'm a senior AI slash machine learning consultant and a Microsoft MVP. And today my session will be on training models, not just machines, and building human-centered AI. And this is a bit about me. Like I said, I'm a senior AI slash machine learning consultant, accessibility and inclusion expert, advocate, founder of Azure AI. I have 4+ years experience in AI accessibility, innovation, and community-driven tech education. And also, I co-founded a news accessibility platform that leverages AI to make news accessible to the deaf and blind people. So, first, I'll start with the problem that we have in the world today, where AI is being discussed. There are emerging technologies that are being originated from various AI technologies. But one critical problem that we often don't come to realize is the fact that not all AI systems are inclusive and accessible to the wider individuals in the entire world. And I'm talking about 1.3 billion people who are waiting for AI to notice them. And the fact remains that most of these AI models are being trained to be able to answer generic questions, perform amazing tasks, but most of them are often not human-centered. They're often not meant for people who are visually impaired or people who are hearing impaired or people who have language barriers and can't access these AI systems. And in the race of building these bigger models, we still often forget these people on the other end of our systems. The challenge we face is that we are building AI for the privileged few, not the diverse many. 15% of the world live with disabilities. 77,000 plus languages are being spoken every day globally, and yet AI serves just an handful of that. And the current approach that these AI systems are using is that you build first and you include later. And it often doesn't happen like that. You could take ChatGPT, for example. If you download the ChatGPT mobile application, you'll see that someone who is visually impaired can't use that system, or someone who might have a localized language they're familiar with won't be able to use that system, or someone who even have neurological disabilities might not be able to use the AI system that OpenAI has released for individuals to use. And this is the result of something that normal fit individuals can access within seconds. People with disabilities are often required to go through the extra mile or find feasible approaches along the middle layer to get access to these models. And the cost is that the excluded users are often left behind the digital race or the AI revolution, and they totally miss the innovation of the entire system. And those who need AI not just to be powerful, but to be present, these are the people who are aiming for people with disabilities, 1.3 billion people currently in the world that want to access these AI systems. First, I'll start with human-centered AI. So what is human-centered AI? It's not just a buzzword, it's about purposeful engineering. So currently, the traditional method of building these AI models, these AI systems, is that you train a model, you create an interface to interact with it, and you bring it out to the public. Oftentimes, an user, it has either little accessibility needs or none at all. But with human-centered AI, you build a model based off user needs. You do an exploratory user research to understand how these AI models are going to be used by the different individuals involved. And when these individuals come on board, you take their pinpoint as user needs and try to create an inclusive design alongside the model being trained. So from the model being trained, you are going to now implement the AI models that are going to be interacting with these users. So with this, you've created an AI system that is human-centered. And creating such system is going to create, create a shift. And that shift is going to change from a one-size-fits-all to adaptive intelligence. So we are no longer building one system that is going to work for a few of the majority, but a system that can adapt to various user perspectives, various user needs, and various user language barriers. And from post-launch patches to inclusion-first design. So instead of building system that solves amazing problem but limits it to little users to use, you create a system that is inclusive first by design and is able to be accessible by these individuals in concern. And from prompt engineering to purposeful engineering, you get to see the wider impact of building such systems that are human-centered, training models that are human-centered. So you just don't limit it to prompt engineering, you try and create purpose of the humans, the users at the other end who really need such systems. And there are three pillars to these frameworks, which I earlier mentioned in the session title: the AI that listens, the AI that sees, and the AI that includes. And we tend to originate it from how can you build or train an AI system that truly serves everyone in concern. The listening part is the AI that hears the unheard. Most people are hearing impaired, and they often can't use AI systems who have to do with real-time speech processing or systems that have to do with audio descriptions and voice synthesis. And for real-time speech processing across accents and languages, the AI has to be inclusive in the sense that it's able to adapt to various users' nuances and be able to create an intermediary layer between the conversation being heard from the AI models to the conversation intelligence for the deaf users. And this can also impact the audio descriptions and voice synthesis of that AI system. And for the AI that sees the unseen, we are trying to add, currently most AI systems use audio descriptions to add taglines to images to create a pillar for people who are visually impaired. But most image description still lacks scene understanding. They can't really adapt to people who are visually impaired. That's why technologies and innovations like OCR and document intelligence are being brought forward to cater for these blind users. And we also have to take note of visual navigation assistance that is going to allow these individuals to easily navigate through their AI systems without fully utilizing self-sightedness. And for the AI that includes, we're trying to build a system. You should build a system that includes everyone regardless of them and their background. So in simple terms, including AI for the overlooked. We understand that different people come from different backgrounds, different people speak different languages, different people have different learning styles, different people have various cognitive conditions, and you try to create an AI system that can adapt to those people's nuances and behavioral factors. So you first of all take note of the multilingual translation with cultural context in mind and adaptive communication for neurodivergent users. Users who have dyslexia or users who have um, hard understanding of learning the concept of these AI systems. And if we're looking at the broader framework to build this system, The Azure AI ecosystem already provides a large amount of tools to make up these building blocks and to create a realization impact to what is being done. The technical foundation for inclusive AI is very, very straightforward. We already have the Azure OpenAI service, we have the Azure AI speech service, the Azure AI vision service, and the Azure AI translator service. So, regardless of any system you are building, at its core, it should be able to listen, see, and include its users. The Azure OpenAI service allows you to access a wide varieties of models with accessibility focused prompting based on adaptive intelligence. And it creates a layer for you to custom fine-tune these specific models based on specific user needs, which can then in turn create that adaptive layer. The Azure AI speech service have access to over 90 plus languages with accent recognition. And as years come on and months go by, more languages are keep on getting added, and you get to diversify it within various use cases. There are custom voice synthesis that you could imply based off preserving personality, and you could also embed real-time translation for multilingual support. The Azure AI Vision creates an image analysis with detailed scene descriptions, OCR technology, object cognitive recognition, that allows you to read concepts using AI vision directly from documents and understand its structure. And for the video analysis, you get to see how diversified the dynamic accessibility can be in terms of catering to people who are visually impaired. And for the inclusion, we are aiming for the Azure AI Translator service, which gives you a layer for you to interact with over 100 plus languages best with cultural adaptation. And you could also preserve with various different use cases, whether it comes to conversation translation, document translation, or real-time conversation translation, which leads to the inclusion layer implementation. And the architectural plan for building models or training models that just don't work are human centered, includes and sees. We look at the architectural pattern, the inclusive AI stack, how to structure your human-centered AI system. The first layer is to start with the data foundation layer. In this layer, we will look at the diverse representative data set that represents various groups within various cultural nuances and various cultural concepts, users of various needs, and try and make it as diversified as possible. You create a bias detection and mitigation pipeline to make sure that whatever data set you are using to train your model is very, very much cleaned and is free from bias using various mitigation pipelines. And you make sure that the data you are gathering is privacy preserved and the data is well collected. And for the layer two, look at the AI services orchestration. Within the Azure ecosystem, there are various services that can be utilized. For example, the Azure AI Foundry software that serves as a software for unified model management. You can use it to manage the various AI services I earlier stated, whether it's Azure AI Speech Service, Azure AI Vision, or Azure AI Translator. And it allows you to utilize the multimodal AI coordination where you could combine various services together to form a full-scale system, whether it's the speech plus vision or speech plus vision plus text or speech plus vision plus text dot video analysis, wherever service that your application utilizes, you can cater it based off the foundational architectural pattern. And it also allows real-time processing with subs of 200 millisecond latency minimum, which shows that your AI system could still perform significantly well, regardless of how much you combine these different AI services together to form an inclusive AI stack for building or training models. And for the layer 3, we're looking at the accessibility adaptation. A WCAG 2.1 Act creates a compliance layer for you to actually build system that really matters. So you could already see that various initiatives or various policies are being brought in forth to make sure that systems being built, whether it's AI or not, are being accessible by default and are able to adapt to various user concerns or user needs. And it's integratable with Assisys technology and is very, very much easy to personalize based off users' experience or adaptation. And for the last layer, which is the fourth layer, the inclusive user interface. Now we've talked about how you've gathered your data, how you've been able to utilize the various Azure AI services. So create an orchestration layer that utilizes the various combined AI services together through a unified model management software called Azure AI Foundry. You've been able to align it with the various available policies. And now it's left for you to create an interface to interact with that layer, the train model. You have to take note of multi-input modularities. For example, you don't just build an AI system that takes text by default as the only option. You could adapt it through various other modularities like voice, touch, or eye tracking, or even facial recognition. And the adaptive output format could be audio, visual, or haptic based off the user needs. That's the adaptive intelligence. And it always has to be context aware based off the response generation. The response the AI model is generating must be context aware based off the user needs. Now we'll look at building AI that actually lists things on a more drilled down level. The speech intelligence for accessibility is the core components you need is the real-time transcription with Azure Speech Service, custom speech models for accent and dialect recognition, emotion detection for contextual understanding, multi-speaker identification for groups conversation, and the implementation pattern is very straightforward. You take in the audio input, you reduce the noise, you create a speech recognition layer, translate based off the user's language after you've detected it, and then you create a context analysis on those voice inputs you've taken, the audio inputs you've taken, and you create the accessible output, whether it's text, sign language, audio, or description. This is building AI that listens. And the key technical consideration for you to take in forward is the fact that streaming transcription has to align with the confidence scoring. How well can your model adapt to the transcription being generated by the audio files it's outputting or streaming? And does it have offline capability for reliable access, or it's only going to be accessible through online mediums? And is it easily integratable with hearing aids or assistive technologies that these persons with disabilities already utilize? And lastly, does it preserve the privacy of these users when interacting with the system through voice processing? For building AI that sees, it's very straightforward. While talking about the computer vision for accessibility, where you are utilizing we're utilizing the following essential capabilities. First is the scene understanding with spatial relationship mapping. You try and understand the scene in which the user is in using various named entities within that user's environment to try and understand what is being talked about. And you use OCRO with layout preservation for document reading. This creates the Azure AI vision layer that allows you to incline your AI model to these persons who have low visual representation or who can't even see at all. And you implement object detection and tracking to make sure that the system is able to track the navigation of various elements, either on screen or out screen. And you also implement facial expression analysis for social context, especially for users who can't speak but can communicate based off their facial expressions. And the technical architecture is very straightforward, where you could take in a video input or image input as example, preprocess it, and send it to the computer vision API from the Azure AI Foundry resource and add a semantic analysis layer from it. From that, you're able to depict if it's negative, positive, or neutral, and use that factor for natural language generation, which will then return an audio description or a text output. This is for persons who can't see, but will want description elements to be embedded within the AI systems they interact with. And for the building AI system that include, here we majorly talk about the multilingual implementation and the diverse implementation strategies for neurodivergent users with various cognitive disabilities. Now we're looking at four core technologies, which is the neural machine translation with context preservation. We're also looking at the cultural adaptation engines for appropriate responses. We're looking at cross-lingual embeddings for semantic understanding and localized pipelines for URL and content understanding. So you take in the user's inputs and try to create a machine learning translation based off the context of that user through context analysis and preserve it for the next pipelines moving forward. You create a cultural adaptation engine that can adapt to the various user cultural backgrounds, their various user needs, before then passing it into a semantic understanding layer that understands the inputs being passed or the outputs being released in more depth, and then align it through the localized pipeline for UI and content visualization. The implementation strategy is also very clear, where we're taking the inputs, which can be input from any language, because here we're trying to be diversified as much as possible. There is creating AI that actually includes. You first of all detect the language, then perform a cultural context analysis on that language, and then align it for translation plus adaptation to make sure that the input of that user is able to align with the cultural preference of the said user, and then create a response generation as the output. For advanced patterns, you create zero shot translation for new language pairs. You make sure that cultural context preservation is preserved in conversations, and multilingual content generation is always embedded within the various aspects of the system. Now, the design patterns for this multimodal system, we have four major patterns. The first pattern is us considering the adaptive interface design. Here we talk about the dynamic UI adjustment based on the user capabilities, and for the progressive enhancement from basic to advanced features. For the adaptive interface design, you try and adapt the UI that the user is interacting with different adaptive concerns, whether it's voice inputs, text, auth messages, or even sign language implementation. And always try to implement fallback mechanisms that will be on the standby when one system fails and the other proceeds. And the pattern two is for the multimodal orchestration. Here we'll talk about the seamless switching between input methods, whether it's voice, touch, or gesture. Because we understand that persons with disabilities have various disabilities that vary from each other, they interact with the system using various methods. It could be voice, it could be touch, it could be gesture. You implement this multimodal orchestration to make sure that based off the user using the system, that's the user needs, it's able to switch seamlessly to the right input method. And you make sure that redundant information are being avoided and all information that the system is outputting or inputting are always reliable across various multimodal methods or various contexts. For the third pattern, that's the inclusive data pipeline, we try and create a diverse data collection pipeline that reduces the bias in the system through a bias monitoring implementation and mitigation pipeline to make sure that there isn't bias in the system. Most of these generative AI are often trained with specific geographic data, which on its own creates bias. So if you are building a system that includes, you try and diversify it as much as possible, starting from the data collection. And make sure that synthetic data generation is always for underrepresented groups. So if data is not sufficient enough from the natural data we are gathering, you could implement a smooth technique to make sure that data being generated that are said to be synthetic are generated for the underrepresented groups in the diversified sets for data collection. And you always try and implement continuous feedback loops to make sure that the model improves with time. For the fourth pattern, the context-aware personalization, we include a user preference learning and adaptation technology to make sure that the system is able to learn based off the user preference at any time. And it's always responsible for the environment context and works based off context awareness, whether it's reducing noise or lightning or the various environmental factors that could hinder the system performance. The accessibility, there could be many accessibility challenges and technical solutions to them, which could lead to common pitfalls. And here I would say some of the ways for you to architect your way around them and mitigate them. The challenge one, which is the most challenge we face with training models, is model bias, which often originates from the data we train our models with. The problem is that AI performs poorly for underrepresented groups. Within the data sets being collected, some groups or some classes may be underrepresented, and which in turn is going to lead to a model bias, which is going to perform less well to these underrepresented groups and perform better to the overrepresented groups. And the solution here is to implement a fairness constraints and group specific evaluation. Here you are going to implement various ways to monitor the progress from the dataset collection and try and create a smooth technique for the synthetic data generation that aligns with each group for specific metric evaluation. And some tools for you to do this still within the Azure AI Foundry portal is the Responsible AI Toolkit for bias detection APIs. And the challenge two is the performance disparities, comes of the fact that which often comes of the fact that there could be latency between various user groups. And the solution to this is that you create an edge computing for the critical accessibility features alongside every AI service you've implemented in the pipeline for the inclusive UI design and training model that is inclusive, you create a computing technique that is able to adapt to each accessibility features while reducing latency within the various user groups. And the implementation for this is the Azure AI portal has an Azure IoT Edge service that allows you to process or train your model locally before then releasing it through the pipeline. And for the third challenge, we have the data privacy, which is the major concern that most users are often talking about if their data is secure or not, or is being taken into account for privacy concerns. And the problem is that the accessibility data is very, very much highly sensitive because persons with disabilities already see themselves as persons who are already underrepresented in the society, and training AI models that leaves them behind is already a big problem. If you try to create a system that includes them by design, then you have to make sure that data privacy is often prioritized across all stages. And the solution is that there are various policies available, the WCJ, for example, and other disability policies and design policies that takes in the fact that there are federated learning and differential privacy amongst various user groups, and you're trying to pin and align your AI model training, right, starting from the data based off those various privacy policies. And the Azure features for this is the confidential computing and privacy prevention, preserving machine learning techniques. And the fourth and last challenge is the compliance complexity. Many developers or many technical builders often avoid building for persons with disabilities simply because they cannot comply with some of the policies or documents that have been put in place, such as the ADA or WCAG. So for you to do this, you can create an automated compliance testing through a CID pipeline that weighs in your system through an automated testing technique and try and align it with the various principles, the various clauses that these different policies have stated. And ethical consideration is also another big part in building AI for inclusive um, uh, people, persons with disabilities, AI that actually sees, yes, and includes. And the moral framework for AI development includes four major core principles, which is dignity, equity, transparency, and privacy. For dignity, we're looking at respecting user autonomy and choice in AI interaction. You try as much as possible to put integrity in the play and make sure that whatever data is being stored in the data and how the user is being able to interact with the system is based off their preference within the different modularities you created for them to utilize. And try and add equity to it where the performance parity is always equal across all the user groups, no matter whether it's for persons with disabilities, persons who are fit, or even different groups within the persons with disability society. And be transparent with the AI model you're training. Explain why certain decisions are affecting accessibility and how you've been able to create solutions to mitigate them. Already, we understand that generative AI systems often have an hidden layer in them, which leads to a black box problem where engineers often don't know how this AI system come about with their decisions. But with building with inclusive design and with better prompt engineering, you could have a fraction of that knowledge and create a transparency layer for these users who will be using the system. And the last, which is often very much important, is privacy. Persons with disabilities are often concerned about their privacy. How are you able to protect the data that are being fed into these AI models? And how are you being able to encrypt them from either attack or release to unsafe arms? And you have to make sure that the techniques you are using are able to protect effectively this sensitive accessibility data, no matter the context and condition. And the technical implementation is to first have concept first design for accessibility data collection, explainable AI dashboard for critical accessibility decisions, user control panels for AI behavior customization, regular algorithmic audits for bias and fairness. So the algorithms you're using to train your models, you have to make sure that it's regularly audited to make sure that it's free from bias and it's always fair. And there are various deployment strategies for building these or training AI models that scale an AI system that actually listens, sees, and includes. And for making these AI systems inclusive and production ready, we have to take note of three key areas, which is scalability architecture, performance optimization, monitoring, and observability. Now you've gathered your data, you've made it free from bias, you've implemented the various inclusive design techniques to make sure that your AI actually includes persons with disabilities, and you actually want to deploy the system. We start with the scalability architecture. How well are you able to deploy that AI system to make scaling as flexible as possible? The Azure ecosystem has an Azure IoT Edge for Azure Edge deployments for real-time accessibility concerns. And you could implement a global CDN content delivery network for multilingual content delivery across various user groups and various user contexts. Implement auto scaling based on accessibility feature and demand. You could have user loads for specific accessibility concern. For example, users with visual impairments would want to use the um, audio feature more, and you could implement an auto-scaling feature to make sure that that particular accessibility feature is available on demand, no matter the circumstances or load on the server. And make sure that your system, try as much as possible to make sure that your AI system or AI model is offline first designed for reliable access, especially for persons with disabilities who may not have access to the right tools or network to actually use these systems that are always fully online. And for performance optimization, you would want to implement model quantization to make sure that no matter how large you've trained your model, you're able to quantize it based off a smaller size and release it for development. The impact of this is that it's going to lead to faster inference and faster response time based off usage by these users. And it's also going to assist with faster integration with assistive devices and technologies that persons with disabilities already utilize, and also implement caching strategies. Data that are commonly accessed by the AI system through queries should be cached for easy retrieval when necessary, instead of only sending requests to the model, which is going to delay the response time. Implement parallel processing to make sure that various servers are handling the various multimodal input methods to reduce load on one server and make sure that output is always being utilized and given out when necessary. Also implement resource allocation to make sure that some accessibility features which are of greater demand are being prioritized over others who are less used. For the monitoring and observability, you could implement an accessibility specific metric such as response time, accuracy by user group, response by each user input model to make sure you're able to track how your users are utilizing the various accessibility input model methods you've implemented and how well they are performing based off the workload. And implement real-time bias detection to make sure that the data that the model is being trained on, taking input for and outputting for, is always ready for real-time bias detection even during production. track user satisfaction metrics to make sure that the persons with disabilities who are using these AI models are satisfied across the diverse population groups. There are various patterns for assistive technology integration, which often come across when you finish training your model. Individuals or companies who already use assistive technology easily integrate them into their existing layers. For ways for you to connect with these existing accessibility tools, we could take note of these three major areas, which by first is the screen reader integration, where we know we already have area markup for AI generated content. We could also utilize structured data outputs for easy navigation and implement custom commands for AI integration. For the voice control systems, you could utilize easy Dragon natural speaking voice control that is easily integratable with already existing systems. Implement custom voice commands for AI features. Some users may want better preference with specific voice types based off their preference, and that layer should be implemented and easily integratable with existing systems, and they should be hands-free operation patterns. For the alternative input devices, such as eye tracking or switch navigation support, you should create an easily integratable layer or components that takes note of gesture recognition or motor for persons with disabilities, and also people who may have brain computer interface for readiness. This is a demo development workflow for inclusive AI design, where we're going to look like the step-by-step implementation process for designing AI systems for persons with disabilities, where phase one is the inclusive requirements. First, you do your user research across the diverse user groups with diverse accessibility communities and make sure that the requirements you are gathering through the software development lifecycle is being met and aligned with the user needs of those particular user groups. And it should be the accessibility requirements should be properly written down with documentation in mind. And the performance target for different groups should also be taken into the inclusive requirement gathering. For the phase two, which is the architectural setup, like I said, the Azure AI Foundry already has a varieties of these software tools for you to utilize for project configuration and for you to utilize the various, whether it's speech service, Azure AI Vision, Translator, whatever service that is required, you can easily find them in the Azure AI Foundry and utilize them. And it also allows you to use multi-service integration planning where necessary, and also implement accessibility testing framework setup that you could easily put inside the pipeline when releasing these models to production for persons with disabilities to test and iterate through. For the core development, implement speech, vision, and translation features, build adaptive UI component that can adapt to the various user groups, integrate with assistive technologies where necessary. Phase 4 is testing and validation. Implement automated accessibility testing that aligns with the WCAG compliance policy to make sure that the AI model you trained or the AI system you build aligns with the already existing policies for accessibility concerns, and make sure that there's performance evaluation across the various user groups within the persons with disabilities community. For the last phase, which is phase 5, you would want to implement deployment and monitoring metrics to make sure that the model you've deployed, which is already in production, is able to align with a monitoring metric for accessibility monitoring. And always make sure that continuous feedback collection is put in the layer to make sure that there's satisfaction metrics collected across the various user groups and improve based off the feedbacks or bugs that might be cited or bias that might be detected in the model trained to make sure it improves the overall user experience of the intended users. And cost optimization might also be a big concern for persons who are building a system for people with disabilities. And we can optimize this using some of the affordable and sustainable metrics like this. The Azure Cost Management Portal allows you to optimize and align the AI services you are using based off the workloads of the people you intend to build it for. And you can also implement reserved instances for predictable accessibility features, features you feel like might be of high demand compared to the others to reduce cost on a long-term metric on a long-term timeline. And also include a spot pricing for non-critical training workloads. Lastly, for the Azure cost management, add resource tagging for accessibility feature cost tracking to reduce cost on features not being utilized. If you look at this on a more bigger scale, you would see that from the starting of this session, I mentioned that 1.3 billion plus users today globally are living with disabilities, and most of them cannot access AI systems being built. A lot of deaf and blind people I know cannot even access the ChatGPT software, which is a big concern in the market. Whether OpenAI is making billions on building AI models that actually perform smartly, including excluding 1.3 billion people, is going to drastically reduce the substantial income that will be generated for such companies. And now, if we're looking at the legal side of things, is if you're trying to implement a legal protection framework, it's going to reduce the ADA litigation risks when these persons with disabilities are often found as exclusive from the design of the system being released through production. And the innovation premium is that inclusive features often benefit all users, which is the best part of it. If you are building a system for persons with disabilities, let's say someone who is visually impaired, for example, and one of the major feature is the audio description or text description of things they can't see. Let's say I'm a visually impaired user and I can't see an image. If you build a system that can describe that image, some users who aren't even visually impaired might see that feature as a very excellent feature and may want to utilize it, which is the very best part of it. Building for disability, persons with disabilities often benefits all users using your system because most of them might even find interest in the features you've already brought in for persons with disabilities. And it's also going to increase the brand value of whatever tool you are building because persons with disabilities are often underrepresented, and corporate social responsibility impact is where that impact is going to be brought in. And for the cost-effective implementation, you could start with high-impact features and go down to low-cost features, which, for example, is alt text, which is very easily implementable for persons who are visually impaired and can't really see images. You can implement alt text as a starting. And you could also leverage pre-trained models before then custom training them based off the specific user group's preference. And implement progressive enhancements to make sure that the advanced features being brought in later on are able to adapt to the system overall stability and performance while implementing various usage analytics to prioritize feature development along the roadmap. The next step is clear. If you feel like there is a bigger need for you to actually build system that truly includes sees and listings, this is a 30-day implementation roadmap that could actually get you on the go. Where week one, you start with accessibility assessment and foundation. You try and set up your Azure AI Foundry, identifying the various user groups you want to cater to, and then establish a baseline performance metrics for you to weigh in your system performance. For the week two, you could implement a technical implementation pipeline that integrate the various Azure AI services and then create a unified system for these persons' disabilities to utilize that system. And if you want to go further in week three, you could implement advanced features for building multimodal user interfaces that can adapt through adaptive intelligence to the various user groups, and implement context-aware personalization, a system that truly understands the current situation of the user and is able to respond and perform based off that user preference. Also, try and integrate your AI system with already existing technologies, assistive technologies, and make sure that the model you are deploying has bias detection enabled and monitoring enabled to make sure that the data that is being fed into the training model is free of bias. And for week four, you could follow through an iterative process of testing, improving, and optimizing. Conduct accessibility compliance testing to make sure that your system is compliant to accessibility policies and for user groups within the persons with disability space. And also make sure that these users you intend to build the systems with are included in the user acceptance testing phase and is able to work across diverse communities. Resources are already available. I'm majorly emphasizing on the fact that the Azure AI Foundry resource is a unified platform that has all these various services enabled within it for you to use for building your system. It has various documentation and quick start um, components for you to begin with. And there are also various accessibility testing tools and guidelines that you can also add alongside your policy evaluation pipeline to make sure that the system you are building aligns with already world existing standards. The call to action here is that if you are building an AI that works for everyone, you have to start with you. You already have the tools, like I've been emphasizing, there are already tools available. Azure AI services for speech, Azure AI services for vision, Azure AI services for language. If you are building within the Azure AI ecosystem, and there are also proven design partners for inclusive systems. The WCAG Act already works as a policy for you to act alongside your guideline metric for evaluating your system to make sure that it's accessibility inclined and it's inclusive for persons with disabilities. You have the knowledge how to implement multimodal architectures. There are resources available online for bias detection and mitigation, patterns for assistive technology integration, and methods for measuring inclusive AI success. And the opportunity is there. Whether you are building specifically for persons with disabilities, you already have the market because according to the World Health Organization, 1.3 billion people are actually waiting for accessible AI because they can't utilize it. In the community, in the persons with disability communities I often interact with, many deaf and blind people cannot use ChatGPT because it's not accessible for them, which is often very bad and is going to drastically reduce the market's return of investment. If ChatGPT even implemented such a solution, you would see that the market opportunity is very, very large. Imagine building a system that could cater to 1.3 billion and pricing it at $2 per month. You know how much you'll be making, which is a great return of investment. So the thing here is that no matter how you are training your model or building the next big AI system or AI agent that can actually solve a real problem, try as much as possible to put accessibility and inclusion in mind to make sure that that system can adapt to various disability problems across persons with disabilities and is always inclusive first by design. And if you start today, you build tomorrow, you are going to include everyone by default. So the question here is not whether you can build inclusive AI or not. The question is, what will you build first? What are you going to build first? Are you going to build a system that is accessible by persons with disabilities, or a system that simply just solves a problem? All AI systems solves a problem, but majority of them are not accessible, inclusive first or accessible first by design. So thank you very much for listening to this session. And I do hope you got a lot from this session in building AI that works for everyone. And the most powerful technology out there is technology that actually empowers others, technology that gives other people the feeling of belonging and give other people mediums for them to interact with these technologies through various accessibility models. And if I have any questions you could ask, and always remember that every line of code you write has the power to include a person or exclude them. And I'll advise to always choose inclusion at each stage of your model development. And with this, we are going to actually build a system and a future that is always more accessible and inclusive. Thank you.
Thank you, Rafiu. Sorry. So, thank you for this amazing session, especially bringing the concern of human-centric and how it can be utilized for everyone. So, thank you so much. I saw like there are two questions for you. One is like, how can we prevent bias when training human-centered AI system? I think you already discussed about this during the session, but still you can just say something about the question.
You say what?
Yeah. So let me repeat the question
Okay,
again.
thank you.
How can we prevent bias when training the human-centered AI?
Okay, thank you very much for that question. So first we'll start with how does bias actually originate in human-centered AI or building AI systems. And the fact often starts from the data you've collected to train these AI systems. So now the fact is that most bias in this data reflects only certain groups. That's bias by definition. For example, let's say you have gathered data from mostly men, or you've gathered data from mostly white people, or mostly from the global north or the global south or in Africa. That's already biased by default. And the solution here is that if you are building human-centered AI, you should make sure that you use data set that can represent different genders, races, disabilities, languages, regions, or cultural background as much as possible. If, for example, you've gathered data and you've seen based off the training you've already started that a particular class or a particular data group um, is more than the other, is often overrepresented than the other, within machine learning and training model, there are various techniques for you to implement or generate synthetic data by creating an overlap. So, for example, let's say I have a data set that have to do with detecting if someone is male or female, and my data set have values that men are often overrepresented than the females. I could implement a smoothing technique that looks at the data set and try as much as possible to follow a pattern to create synthetic data for the underrepresented group. And another thing to take note of is that bias can also originate from mislabeling. That's why systems or AI organizations often utilize labeling your data is also another critical part of data training. If biased labels lead to biased labels can actually lead to biased AI detections. Let's say a data that is meant for female person is labeled as male, that's already biased detection. So train labelers, you could train AI systems within the AI pipeline called labelers that are able to identify various diverse backgrounds and audit the labels regularly. And this is going to avoid assumptions. For example, is an angry face equals to a male, or is poor English equals to uneducated? So if you're able to train labelers that are going to be embedded within the pipeline, you'll be able to remove this model bias in human-centered AI. And you could also implement a human in the loop system where uh, let's say, for example, AI, we already know that AI systems hallucinate or AI systems can be context unaware. You can implement a solution where diverse users, let's say during testing or when communicating with people with disabilities, they allow you to interact with real people who are going to flag that, okay, at this particular time, at this particular stage, this AI system is not fair or is biased. And the AI system can take this through its feedback loop to either retrain the model or correct the pattern it's using to generate data. There are various other methods for you to utilize, but to save time, these are some of the key ways for you to reduce bias in human-centered AI.
Yeah, perfect. I think you perfectly answer this how we can prevent the bias, and yes, that concerns are valid as well. So one of the audience has requested it. Is it possible to share the PPT with them?
Yeah, I think I'll share it with you, Ridwan. So
Uh-huh.
possibly you could share it
Yes,
after.
so I can post in a group, and then from their audience or the attendees who is, I mean, it might be helpful for other as well.
Okay.
All right. Uh, Thank you once again, Rafiu, and thank you so much for this wonderful topic coming with the human-centered AI. I mean, that's the best thing we can do. Like the AI is not only for the person who